Hello and welcome. It's been a while since I've made a Sudoku solution video in the style of Cracking the Cryptic, so I may be a bit out of practice with it. Cracking the Cryptic's own video is titled "One of the easiest and most beautiful Sudokus ever," with the adjectives emphasised in capitals. This has me wondering, as they don't usually show us easy Sudokus, does this mean it's one of the easiest Cracking the Cryptic have showcased, or it's easy when you know how, or it really is a very easy puzzle? Let's see. Confiable by James Sinclair. Normal Sudoku rules apply and all clues are standard. Killer cages. The sum of the digits inside each cage is equal to the small number in the top left corner. Arrows. The sum of the digits along an arrow is equal to the digit in the connected circle. Digits in cells are separated by a black dot and have a digits in cells separated by a black dot have a 1:2 ratio. So, looks like it's partly a standard Sudoku, partly a killer Sudoku, and then there are the arrows and black dots, both of which I've seen a few times before. Now, shall we have a look at the puzzle? Here it is. Not sure why. Something seemed to have gone wrong with my layout, but not to worry. Yes, these are the killer cases. Oh. Looks like there aren't any standard Sudoku clues, givens, whatever you call them. Where do I start? Some would say at the beginning, but where's the beginning? So these two circles, these two circles add up to this one, and these two add up to this one. Therefore, these two sum to 14. So they've got to be either 5 and 9 or 6 and 8. If there's a 9, then the highest number that can possibly in here is an 8. So it will be, for instance, 8, 1, 2, 3, if that's the case. And if these are 8, 6, then it'll be 7 plus 7. Hang on, that doesn't make sense. It'll be 8 plus 6. Oh yes, these can be both 7s, as these don't see each other, so they can be the same. You could say I've been doing too much killer Sudoku, or maybe too much Kakuro, but I don't really have that excuse. What can I deduce about this? This is at least 3, and this is at least 3. So if this is 3, then these two sum to 13. And if this is 9, then these two sum to 7. It certainly doesn't look easy. And this page in the top left doesn't really have anything going for it apart from the sum and the black dot. Yes, we know that I know that a black on either side of a black dot, the only possibilities are 1, 2, 3, 4, 6 and 8, as it's got to be either an even number or less than 5 in order to get the 1 to 2 ratio. Do I need to do something with the remaining? Ah, bother. You see, is that's happening because I'm out of practice. Oh yes. Maybe can we use what Simon refers to as the secret? The 9 in a box always sum to 45, so these sum to 31. I can't see a way that this helps me. The 9 can't be in here, so it's got to be in here somewhere, and if one of these is the 9, then the other 9, if 9 is here, then 9 is in one of these two, and if 9 is here, then 9 is in one of these two. So either 9 isn't here, or these are 6 and 8. Or these are 7 and 7. I don't seem to be getting any leads. This is just the same as this. All the arrows are of length 2. This can't be 1 or 2 as. In order to make the 20 sum, and that means this cell is either has the same possible values plus 2 because of the 4. Probably doing a lot of things that don't actually help me at all. Maybe I can think about a bit more about what these are, if, depending on what these two are. If these are 5 and 9, then nine has got to be in here no matter what. That leaves 22 in the sum, as all these add up to 31. Doesn't seem that I can deduce anything useful. The one thing that's clear is that this isn't an easy puzzle. There's either a 3 or a 6 in here. Possibly, no, that doesn't follow. I'm getting confused. Either there's a 4 in here or there are 3 and a 6 in here. This is 3, then this is 6, and these are 8 and 9. And 1 and 2 are somewhere in here, as they can't be here because of the arrow. If this is 4, then this is 8, and these are 7 and 9. Either that or this is... rather, if this is 4, then this is either 2 or 8, but this is still 7 and 9, either way. This tells us that 1 can only be in one of these 3 cells. The smallest number we can put into this 20 is 3, to make 3 plus 8 plus 9. If this is 6, then this is 3, and these would sum to 14, and the only way to do that is 5 plus 9. And if this is 8, then this is 4, and these sum to 12. But it looks like there are two possibilities here. 3 plus 9 or 5 plus 7. So 9 is in here. 9 is definitely in here, unless this is 8 and this is 5 plus 7. Sorry. It's a bit annoying that I can't seem to get anywhere. What could the key be? Must be something obvious that I'm missing. Think about the possibility that this is 8 again, 8, 4. If it's 8, 4, 5, 7, then this leaves 1, 2, 3, 6 and 9. So that we make these either 3, 6 or 9. If this is 9, then this could be 1 and 8. It can't be 2. So, 1 and 8 or 3 and 6. Can I do any thinking out the possibilities in here again? If this is 5, then this is either 1, 4, 2, 3, and the 9. Still, whichever it is, there are still plenty of possibilities. But what is in here tells me what is in here, because if this sums to 9, then 1, 8, then 1 is taken, so this has to be 2, 3, and this is 2 or 3, then this has to be 1, 4. Thinking now. Not sure if marking them like this actually helps me at all. And if this is 4, then likewise this is 2, 3. So if this is 1 and 8, then this is 2 and 3, and so 4, 5, 6, 7, 9 are the numbers in here. Actually, it doesn't look like this helps me. There'll always be one of 1, 2, 3 and 4 as well, and then all but one of the higher numbers. Actually, I'll try enumerating the possibilities like this actually. 1, 8, 2, 3. And just note them in here. They're not actually notes of what's in that square. I'm just looking at the possibilities. 2, 1, 4. So that leaves 3, 5, 6, 8, 9. If it's 3, 6, then this makes it 2, 5, 7, 8, 9. And if it's 4 and 5, then this, hang on, then this is 2 and, these are 2 and 3. 1, 6, 7, 8, 9. This tells me something, I think. If these are both 7s, then there can't be a 7 in here. But there can't be a 7 in either here or here, as those two have got sum to 7. So that tells... No, sorry. So this can't... So 7 can't be... These can't be 2 7s. Therefore, 9 can only be here if these two are 5, 6. These are the possibilities under the case of 5, 9 in here. What are the possibilities of under 6, 8 in here? If this is 1, then this is 7, and these can only be 2 and 4. And if this is 2, then this is 6, and this can only be 1 and 5. But if this is 3, this has got to be 5, so that means this can only be 2, 4. Yes, that's all the possibilities. What does this tell me? If it's 1 and 7, then 2 and 4, this leaves 3, 5, 6, 8, 9. If it's 2 and 6, then 1 and 5, leaving 3, 4, 7, 8, 9. And if it's 3 and 5, then 2 and 4, leaving 1, 6, 7, 8, 9. Don't really... this tells me something. No matter what the sums are... yes, no, it doesn't, because we already know that 9 can still be here if 9 is here. I'm getting confused at times. if 6 and 8, is also guaranteed to be both an 8 and a 9 around the outside. Hang on. Just realised something. This here, maybe I can deduce something, or maybe not. 22. There can't be anything less than 5 in here. These have both got to be between 5 and 8 inclusive, because this can't be more than 9. What are the possibilities? 5, 8, 9. Can't be 5, 8, 9, because 8 would, if this is 5, this has got to be 8 because it can't be 9, which makes this the 9, but this also has to be 9. Those two see each other, so so this is 6, 7, 9. So I can place a 9 here, finally. So the 7 can only have a 1. As the other number along the arrow, in order, as this can't be more than it, can't be 9. So if this is 7, then this can only be 1 and 8. And the same would apply if this is 7, then 1 and 8. But if this is 7, 1, 8, then this can only be 6. This can't be 1 because it sees this. So this has got to be 6, 2, 8. So these are both 8s. A 1, 2 pair and a 6, 7 pair. This leaves 3, 4, 5, 8 in the rest of this box. This doesn't actually help me. I guess these are just notes and not candidates for those squares, so I can ignore the red. But this, because this is 8, that means this isn't 8. Whoops. Neither is this. So these are 5 and 9. We don't know which way round yet. So these are no longer relevant. Eight's here. This means there can't be an 8 in here. Therefore, the only sum that works is 4, 5, 6, 7, 9. This means, whoops, these are 1, 2, 3, 8. So the 9 is 1 plus 8, and the 5 is 2 plus 3, but we still don't know which way round they are. No, this isn't 9, because one of these is a 9, or a 5, because one of these is a 5. I've spent nearly half an hour on this already, being stuck for quite a lot of this time. Now, if this is 3, then this is 1, 2, which would... And the 1 2, or 2 would form a pair with this 1, 2. But we don't know that it's a 3, so... Hang on. Oh yes, then that would make this 13, which could be either 4 plus 9 or 6 plus 7. If this is 4, then 1, 3, which would make this 12. Can't be 3, 9, because of the 1, 3 here. Can't be... 4, 8 because of this, so this would have to be 5, 7. If this is 5, then it could be either 1, 4, 2, 3, and this would make this 11, but now this doesn't look likely to help me. Oh, we now know that this is at most 7, therefore this is at least 9. Therefore, okay, that's be either 2, 7, 3, 6, or 4, 5. Two, 7 would tell us that this is 1, 6. Which, actually no, if it's 7, this is 7, this is 2, this could still be 2, 7. Well, this is 16 plus that's 24, so that would make these sum to 21. Not sure that fact helps me at all. Did these tie in with these at all? And we only know that this is at least 9, but either way it can't have a 1 here. If we have 1 and... No, we have one of these pairs is 2 and 3. No, that doesn't help me either. Ah, actually, If this is 5, then this can't be 2, 3, because one of these has got to be 2, 3, which would block both 2 and 3 from one of these. So 5, if this is 5, this would have to be 1, 4. And moreover, the 1 would have to be in the same row as the 2, 3, so that the other one can be 1, 8. If there's a 1 in either of the, actually if there's a 1, 2, 3 or 4 in either of these cells, which there's got to be, then it'll tell us which is which of these. Maybe a 4 won't, but actually the maximum is 7, so there has to be a 1, 2 or 3 in here. If this is 1, this is 2, 3, this is 1, 8. If this is 2, this is 1, 8, this is 2, 3. Let's think about this. This is 1, this is 2, 3. This is 1, 8. Still a full set of possibilities for this cell, I think. If this is 2, then this is 1, 8, this is 2, 3, which bars 3 from here. If this is 3, then this is 1, 8, this is 2, 3, which means this could be 1, but not 2. This could be 4. And if this is 4, this is 2, 3, this is 1, 8. Only rules out 1 from here. This doesn't really help me. What about if it's 6, then this can only be 1, as the maximum sum is 7. So I make this 2, 3 and that 1, 8. This is 5, then either this could be 1 and this 2, 3, or this could be 2 and this 1, 8. Doesn't get me anywhere. Let's see if I can see anything anywhere else. This is noticed. This is weird. This is the same as this. So the grid puzzle is actually symmetrical about this diagonal, except for 2 details. One is the black dot here, and one is these 2 arrows. this is 3, then this is 1, 2. Then we'll put 1 and 8, 2 and 3 in. Doesn't help me. Maybe it does, but I can't see how. I'm restricting what these can be at all. If this is 3, then 1 and 2. Don't tell me anything. If this is 4, then 1 and 3 likewise. If 5, then it could be 1 and 4 or 2 and 3, but it can't be 2 and 3 because either these two or these two have to be 2 and 3. So 5 would mean this is 1 and 4. Only if it's 6 or more, then it could be. It can only not be a 1 in here if this is 6 or more. We don't know what TI should be barking up. These sum to 25, but I don't think knowing this helps me either. If this is 8, then this is 4 and these sum to 17. And these are at least 6, so these would sum to at most 11. These 3 together sum to at most 19. Ah, 6. This is 6, this is 3, this is 8, this is 9, these are 8 and 9. But I will need this to sum to 13, I think. Oh no, because 19 is only the maximum sum of these. We don't know. It actually is 19. 3, 4. 2, 3, 4 is the minimum. So 29, this makes 16 the maximum of this sum, so 15 the maximum of the two in here that aren't 1. Oh, there can't be a 4, 5 or a 9 in here. No, yes there can, because 5 is here, there can still be a 5 here. If 9 is here, there's still be a 9 here. Nine is either, whoops, 9 is either in these two or in these two, one of these two, one of these two. Therefore, no, that doesn't. Actually, at least one of these has a 9 in, but I don't think that helps me. What could the key be? Why can't I see it? Are there any I can say about this 21 sum? These are at most 6 plus, no, 5 plus 7 is the maximum because of this 6, 7. It's either 6 or 7. So these sum to at most 12, so these sum to at least 9. This likewise, that at most 5 plus 7, so this is the sum to at least 9. If this is 5, 7, then this is 6, this is 2, then this is either 3 or 4, which means one of these two is a 1. This is neither 5 nor 9 because of this. Ah, 2 can only be either. 2 can only be in these cells. Not sure that helps me. Ah, hang on. If this is 2, then if this isn't 2, then this is 1, 2, and something else. Between 3 and 8, so the range of this would be 6 to 11, so these sum to 25, so the range of so the range of this is no. Oh no, because either of these could be 9, so the range is 6. The range of this is, if one of these is a 2, then the range is 6 to 12. And with this being 20 and this being hence being 25, this means the range of this is 30. The range of these three, the range of the sums of these three is 6 to 9. Oh, it's got dark in here. I guess. It's been 55 minutes already and I've still managed to fill in only 3 cells, so I think I might have to admit defeat. I've explored many ideas but got nowhere. Actually, this can't be a 9 and a 5 in here, because I found out earlier the only way that there cannot be a 9 here is if this is 5 plus 7 and this is 8. Does this tell me something? The idea that there's a 9 in here. 5, 7, 8, 4. That leaves 1, 2, 3 and 6. Which will in turn put 3 and 6 in here. And 1 and 2 in, and the remaining cells here. So try a bit of trial and error. No, I shouldn't have to use trial and error in a Sudoku, but if 9 and here, then actually this 9, yes, that would mean that both. Oh, is that if 9 is here, then 9 can only be in here in this box, and can also be only in, because 9 is here, it has to be in here. Oh, so I actually had a, so regardless of, oh, no, oh, this doesn't make any sense. Oh, yes it does, because 9 is only original, so it's perfectly possible to have a 9 in these. How could I not realise for ages I made that mistake? So, the 9s in these two boxes are in these two and these two. Still not sure it helps me get anywhere. So this is at least, we've ruled out one from these cells. No, how have we ruled out one from these cells? Maybe I was just getting confused about that as well. The only number this can't be is 8. So this is at least 10. Therefore, this is at most 6. I can rule out the 7s, and likewise from here. Just as I was about to give up, I discover a new lead. So I'm still not sure it actually helps get me anywhere. 16. One of these is a 9. That means the rest sum to 7. Where does that get me? That might be a big clue. 1, 2, 3, 1, 4, 5, 2, 4, 6. Likewise here, so these aren't 4. So I'll fill this in actually. That means these are 3, 5, 6 and 7. That forms a quadruple. 3, 5, 6, 7. So that leaves these to be 1, 2 and 4. And I can use the same logic here. I'll put the light on actually. I'm not sure if this, as the big question is, has this actually helped me in any meaningful way? If this is 6, 1, then this is 2 and 4. This is no, this is 6, 2. This is 1, 4. This is 7, 1. This is 2, 4. Similarly, if it's the other way around. This can still be 3 if this is 4. 1 and 2 aren't in the same row in here because of 1 8 and 2 3. So either maybe they're still be 1 2 making a sum of 3. No sum of 3. No, this doesn't seem to help me. If this is 1, this is 9, this is 2, this is 4. If this is 2, this is 9. This is 1, this is 4. This is 4, this is 9. If this is 9, then one of these is a 4 and the others are 1 and 2. Doesn't get me anywhere. What does this tell me? Oh, here's 3 5 6 7. So 1 and 2 can only be here. What does this tell me? Can I do something similar here? Yes. Ah, I think I have something here. One of these has to be a 4. Oh, I know that anyway. This is a 1 or 2. Ah, so neither of these can be a 3. Because that would force it to be a 1 plus 2, which makes this. I think either. No. If it's this as a 4, then that's 3 1, which. No, 2 4, it breaks this, so. If this is 5, then. No. Or maybe. If it's 1 4, then 2 4, no. 2 3, then 1 4. Ah, so 5 2 3 1 4 is possible. No, it isn't, because there's got to be a 2 in the 2 in this box has to be here, so 5 is out. And it's the same here. This has got to be at least 3 plus 4, so at least 7, so 7, 8 or 9 in these. Does this help me? That is a good question. 20. At least 15. 20. 15 to 17. 37, 39. Hang on, this doesn't make sense. 35 to 37. Ah. So, this is a big lead. These now must sum to 10. You know why? There's 4 cells, all different, can't sum to less than 10. And it's the limiting case where these sum to 15. So, one, two, three, four. So all the 3s and 4s are ruled out of here, and 7, 8 are ruled out of here. Ah, so I've got it now. 5, 9, 14. So this, by the killer Sudoku cage, this is a 6, and this is a 3. I have 1, 2, 4 triple here. So in the rest of these is 5, 6, 7, 8, 9 in some permutation. What's that tell me about the 7, 8? They're either 3, 4. Hang on, this can't be 5 because of this 5, 9 pair here, so no, this is 3, 4, so this is 7. And this is 8. This is a 3, 5 pair. Ah! The big question that's remained unanswered since the beginning. This is 9, and so this is 5. I seem to be really making progress now. So we said already one of these pairs is 2, 3, and one of these is 1, 8, and now we know which is which. That eliminates some stuff from here. 3. 2 3 pair sees this, so this is 4. This is 3. Where's the 3 in this column? It can only be here. So this is 1 2 9 4. No. 2. I can fill this 6. 1 4 3. This is a 5 7 pair, so 7 isn't here. This pair links to this pair, so no 5s elsewhere in these 2 columns. 5, so 9 5. This is a 1 2 4 cyclical group, a big cyclical group actually. One of these has got to be a 7. Do you know why? Because if neither of these are 7, then we have 5 6 here and 5 6 here, and nothing can possibly tell us which way around it is, 5 6 5 6 or 6 5 6 5. So let's eliminate 7 from these. Oh, I can also eliminate 7s because of this slicing and slotting. Nine. Right, that's slicing and slotting again. Is here. And these 2. Can I deduce anything else about this? 6 is here. 8 is in one of these 2. But 7 could still be in any of these. What's left in this column? 6 and 8. And what's left in here? 2, 5, 7 and 9. Two, 5, 7, but we can't place 9. Now down 9. Oh, 3, so 2 and 1. So 2 is here. So this is a 5 7 pair, so this is a 3 6. That's a 5 7 pair, so this is a 3 6 pair, and that rules out 6 from these here, and so So this is 4. Ah, so I can complete this now. 8, 1, 3, 2. So 8 in this box is here. Still can't narrow down to 7. 6. 6, 9 pair here, so this isn't 6. Ah, 3, 6. So, not sure that helps me actually. If these are 3, 8, then we have 3, 8, 3, 6, 6, 8, and 2 possibilities, and 3, 8, 6, 3, 8, 6, or 8, 3, 3, 6, 6, 8, and nothing can make this solution unique. Therefore, one of these has to be a 5. Therefore, these aren't 5. And therefore, by slotting, I can place and narrow 5s down to, 5 is here, so I can place 5 straight away here. All the arrows are, all the killer boxes are completed. Killer boxes, killer cages, and all the arrows are completed, and the black dot is completed, so it is just Sudoku from here. Oh, this killer box isn't complete, but we know what's in it. Why do I keep saying killer box? Let's see what I can do. 4, 6, 7, 8 in these. Okay, 7. Okay, I put 4 here. Do you know why? This can't be 4 because of this 1, 2, 4 triple. Oh, the other one's a 6, which I can't narrow down. What about this one? One, 4, 6, 8. No, 1, 6, 7, 8, 9. 9 will only fit here. 7 can be here or here. 1 can be here or here. 6 only fits here. And 8 only fits here, so I can complete this box. I've almost completed it. Do I just need to follow the reds now? Getting there. And I've solved it. Just as I was about to give up. So we got to an hour and I felt I was really stuck. But then I've found a lead. I'm not sure how I finally found a lead, but it happened, and now I've managed to solve the puzzle. Thank you for watching.